So this controller is to control the hopper, and this 34UR, this controller is to control the ball, and this controller is to control the linear feeder. We make it for demonstration, not saying that small ball must use such bigger controller. This is for bigger ball, but here is just for a demonstration in the exhibition. This is the equipment. The machine is made for the demonstration for our assembly show in Rosemont Convention Center in Chicago. So the parts drop here, and here is the sensor. Here also a sensor. This sensor where goes to this linear feeder controller. It will control the linear feeder stop. And this sensor is a photoelectric sensor. It goes to this controller. And we use this controller, the linear feeder controller, to give a signal to the ball feeder controller. So once the sensor here have a signal, the linear feeder stop and then gives a signal to the ball feeder. The ball feeder, if you want the ball feeder stop, we set the logic. Only here, this sensor have signal, and this linear feeder gives a signal. Only when both the logic is end, then the ball feeder will stop, just like here. And then when this is a rod sensor, it's connected to the hopper, and when it gives signal, the hopper will automatically feed to the ball feeder. Now it totally stopped because so here the ball feeder also gives the signal to the hopper. So when the linear feeder stop and the ball feeder stop and the hopper stop, signal comes from here. You see here the ball is full. If I put the ball back here, because I set 2 seconds. After 2 seconds, it will restart again. Okay. So if we check the signal here, this is the one sensor, and this is 3 and 7 is 2 sensor collections of this controller. This sensor use one of the ports, and then it gives from this controller to this controller the logic. So just now we set it goes again. So this is one sensor. This is for this sensor. And this is for the signal comes from here. And now we set the logic. This is AND. This is the logic AND. So when both the sensor gives signal, the ball will stop. Okay. And you can adjust the port sensor type by this symbol. If you here is NPN, means the NPN sensor goes to the port. This version is NPN and PNP compatible, so you can make it NPN or R2. R2 means it will start detection of the sensor type automatically by this controller. By default, we set it to be R2, but you can choose to be NPN or PNP. Yes. Then make sure here the C port or E port means the sensor port of this controller match with here the linear feeder 24 volts output sensor type. If here we choose NPN, then here it must be NPN. If here we choose PNP, here must be PNP. And this sensor, by this sensor, if you press, it will goes to. It has 10 groups. If you press, the third is for the output, the fourth is for stabilizer of the feeding speed. The fifth group is for on-off of signal of port C. This is for DC output, the 24 volts DC output. This is counter. Group 8 is communication, RS485 communication. Group 9 is safe. 10 is monitor. So all these parameters you can monitor in real time, and you can remember the number here. It is belong to 10 and 7, so 10.7. Then you can set it. You can set it here on group 1, which parameter you want to monitor. Just like here, we want to monitor group 2, number 2. It means group 2, number 2 is user voltage, means the real-time voltage. It will show you how is the real-time voltage. Here is group 10, number 2, means 10 group number 2 frequency. It's a real-time frequency of this. We use it to demonstrate this linear feeder. So it shows the frequency change of this linear feeder. Then we put this. This is the main menu. It shows real time user voltage, frequency, and voltage, soft start, soft stop. These parameters you can choose. You can choose from the groups. Okay, last time we talk about the D port must have output stabilizer on off. DC, the DC output means this signal wire. It gives the DC signal to this controller. So the DC output here, you check. This is delay. port D delay time, port D type, port D type, we choose the MPN, right? And you can choose it. Also PMP, PMP, MPN, PMP, right? Right. Why we choose it MPN? Because inside the cabinet we wiring it earth and singular, 2 ports, earth and singular. Then we choose MPN here. If you wiring the D port, you choose singular and 24 volts DC. Then here you set it to be PMP. Also here you set the C port. If you connect to C port, then you also need to set the C port to be PMP or R2. R2 means it will detect by the controller itself. Yeah, so check 2 seconds and then start again. Okay, this is very interesting machine. If you have any problem or if you are interested in our controller, you can contact with me, Cora Wang from CUH. My email is wr@cuhng.com. You can also add my WhatsApp. It's 0086, that's our country code, and then 15366177576. That's 0086-153-6617-7576. Okay, add me anytime by WhatsApp. Thank you. Bye bye.